In the last video, we said AI is a system, not a model. Here's the proof, in the one place executives actually look: the bill. When companies cost out a real AI application, the model is only about 30 to 40% of it. The other 60+%, orchestration, retrieval, guardrails, monitoring, integration, sits outside the model. So if the model is the small slice, what's all that other stuff? That other stuff is the system, and designing it is what this video is about. One number makes it concrete. In production AI traces, about 69% of the tokens going into the model aren't the user's question at all. They're system instructions, policies, and tool guidance. The thing you typed is the majority. Let's design that system. So where does that 60+% actually go? It goes into components most people never picture when they imagine an AI app. Orchestration, deciding what happens next. Retrieval, fetching the right data. Guardrails, checking the output. Monitoring, watching it in production. Integration, wiring it into the tools people already use. Each of those is a component with one job. Understand the components, and you understand AI system design. Why care about architecture instead of just prompting? Because 3 things you care about are decided by the system, not the model: cost per request, risk and compliance, and whether anyone actually adopts it. Get the architecture right, and a good enough model performs well. Get it wrong, and the best model on the market still disappoints. So let's reframe. Instead of an AI app, think in components. Each component has one job. Each has its own failure modes and its own metrics. When something breaks, you don't ask, is the model bad? You ask, which component failed? That single shift is most of what AI system design is. Here are the 7 building blocks of a modern AI application. 1. The interface, where the user asks, usually through an app talking to your system over APIs. 2. Orchestration, the brain that decides what happens next. 3. The model, the LLM that reasons and generates. 4. Retrieval, fetching the right context, often using RAG over a vector database. 5. Tools and actions, where the system actually does things, through more APIs. 6. Guardrails and governance, safety, permissions, policy. 7. Monitoring, including evaluation, so you know it's working. Most teams build 1 and 3. The reliable teams build all 7. Let's zoom into the component people ask about most: retrieval. When the model needs facts it wasn't trained on, your policies, your docs, you use retrieval augmented generation, RAG. You turn documents into embeddings, store them in a vector database, find the most relevant chunks for a question, and hand those to the model as grounding. The model stops guessing and starts citing. We'll go deep on RAG in its own video. Here, just know it lives inside the retrieval block. The order you design these in matters. Before you pick a vector database or a model vendor, answer these in order: jobs to be done, data sources, retrieval needs, reasoning needs, actions the system can take, guardrails, then metrics. Tools come last, requirements come first. Most failed projects invert that. Let's make it real with a different example than last time. Say we're building a customer support assistant. It answers product and account questions and can take a simple action, like checking an order status. Watch how every one of the 7 blocks earns its place, including the tools block, which finally gets to do something. Interface, a chat widget on the support page over an API. Orchestration, classify the request. Is this a question or an action, like where's my order? Model, reason over what it's given. Retrieval, RAG pulls the right product docs and help center articles from the vector database. Tools, call the order status API when the customer asks about a shipment. Guardrails, never expose another customer's data. refuse refunds above a threshold and hand off to a human. Monitoring, track resolution rate, escalation rate, and cost per conversation. Same 7 blocks, different use case. That's the whole point of a reference architecture. No architecture is free. Every component is a trade-off. More retrieval means better grounding, but higher latency and cost. More autonomy in the tools block means more capability, but more risk. Tighter guardrails mean safer answers, but more refusals. Good design isn't maximizing every block. It's choosing the right tension for your risk tolerance. One risk deserves its own moment. Permissions. If Retrieval can fetch any document, your assistant just became a data leak engine. Access control belongs inside Retrieval, not bolted on later. Design it in from day one. How do you know the system works? Not vibes. Metrics. Groundedness. Is the answer backed by retrieved sources? Task success or resolution rate. Did it actually solve the request? Latency and cost per request. Is it usable and affordable? And adoption. Are people coming back? Evaluation isn't a one-time test before launch. In production, it runs continuously. That's the monitoring block doing its job. 5 takeaways. 1. The model is the cheap, small part. Most of the cost and the design work is the system around it. 2. That system is 7 building blocks: interface, orchestration, model, retrieval, tools, guardrails, monitoring. 3. RAG, vector databases, APIs, and evaluation live inside those blocks. 4. Design requirements before tools and treat every block as a trade-off. 5. If you can't measure groundedness, success, cost, and adoption, you're not in production. So here's the whole idea in one line. The model is one box. The system around it is the work. Get that system right, the retrieval, the guardrails, the monitoring, and even an average model performs. Get it wrong, and the best model on the market still disappoints. Now, the single component people ask about most is retrieval. How an AI answers using your data, not just what it was trained on. That's the next video. RAG Explained. How AI answers questions using your own data. If you're building anything on your company's documents, watch that one before you start. Follow for practical AI system design. I'll see you in the next one.